Greetings again. We are back with another video, and this time we'll be doing question number 5. It's based on logarithmic functions. Like I told you in the beginning that the logarithmic functions and the exponential functions, they are just the inverse of each other. Like they're big friends, you know. Let's not waste time talking. Let's get into this problem here. It says on top, logarithmic functions problems. It says the graph of k of x is equals to log 2 of x. Log base 2 into x is sketched below. This is log base 2 into x function. We can see that the domain of the exponential function is the range of logarithmic function, and the range of exponential function is the domain of this logarithmic function here. Let's answer the question here. It says write down the coordinates of b. Like I said, if there is no plus q here, b will always be it will always intersect at 1 here. It will always intersect at 1. And remember, in the previous video we found that the coordinate of a, it was here in the logarithmic function. The y-intercept of the exponential function becomes the x-intercept of the logarithmic function. These two cooperate well with each other, so we can write down the coordinates of b as 1 and 0. 5.2. Let's see what it wants. Write down the domain of k. The domain of k. I told you that the range of the exponential function is the domain of the logarithmic function here. So the domain becomes x has to be greater than 0. X cannot be 0, but x has to be greater than 0, or you can write it in this format. X is the element of 0, where 0 is not included, to positive infinity, like this. 5.3. Let's see what it wants. It says write down the range of k. The range of the exponential functions becomes the domain of the logarithmic function, and vice versa. You know, they say we must write the range. We can see here that range can be any number. Y is the element of real numbers here. Y is the element of real numbers. This is the correct way of doing it. Also, you can say that y is the element of from negative infinity to positive infinity, like that. 5.4. Let's see what it wants. For which values of x is k of x strictly decreasing? We want to know for which values of x will we put into this equation, and it will give us a negative value. We can see that if we put any value less than 1, any value between 0 and 1, where 0 is not included, we will get a negative y value. To write it, we can say 0 is less than x, where 0 is not included, of course, and is less than or equals to 1. 1 is included there. I believe, yeah, let's put in any value, like Let's put in 0.5 and see if it can give us a negative value. We said that log, let's put base 2 here. Yes, base 2, and let's put half there, 1/2. Of course it gave us -1. Let's put in another number less than 1. Let's put in 1/3. Of course it gave us negative value there, so we are correct here. 5.5. It's 5.4.2. For which values of x is k of x increasing? It is only increasing when x is greater than 1. When x is greater than 1, this is when this graph here is increasing. This is 4.2, 0.1, 5.5. Write down the equation of k, the inverse of k, in the form y is equals to, it will give us an exponential equation, but like I told you before, remember that 8 2 to the power 3 is equals to 8. 3 is equals to log base 2 into 8. Here we have log 2 into x. Y is equals to log 2 into x. We swap the x and y values. X is equals to log 2 into y. Now we solve for y. Let's see here. Y is in the same position as 8, so we can write y in front here. Y is equals to 2 is in the same position as 2 here, you can see, so we can write 2 here. And x is in the same position as 3 here, so we can write x here. This is y is equals to 2 to the power x, or we just say 2 to the power whatever is here is equals to y. That's how you do it. But I think we're done with this question. I will see you in the next video where we will be doing the last function. So I will see you in the next video. Bye.